Let's look at another problem from the topic applications of derivatives. So how it goes is, for some x which belongs to this interval, right? Some x which belongs to this interval, define a function. In fact, the function here is defined to be this, right? The function here is defined to be this. Then your f has a local maxima, minima at pi, and a local maxima at pi, or reverse, or local maxima at both pi and 2 pi, or local minima at both pi and 2 pi, right? That is those are the options. So how it goes is, you have a function, you know the interval, right? And in this interval, you need to find at which points will you have local maxima or local minima. So that means you need to find critical points, because only at critical points you have local maxima and local minima. What do you mean by critical points? Where your derivative of a function is either 0 or undefined. That means does not exist, right? Any of these two are critical points. So here, if I have this function, I first need to find its derivative, right? So I have a function which is in the form of an integral, right? So obviously, there is one way. You can obviously integrate this function. You can first integrate this function, which is not that easy to integrate, and then put x in that, get the function, and then differentiate it, right? Otherwise there is something called as a Newton's Leibniz rule, where you can directly differentiate this integral straight away. So if I have a function f of x, which is some h of x to g of x k of t dt, something like this, then if you want to differentiate this, the way you are supposed to do this is, instead of t, put k of g of x, put g of x inside this, and differentiate g of x, subtract, and now put h of x inside this, and differentiate h of x. This is the way you do it, right? So I'll do the same thing here. If I want the derivative of this function, so what I'll do is, I'll first put x inside this. Wherever t is there, I'll replace that with x. I'll differentiate x with respect to x, which will give me 1, minus, I'll put 0 inside this, so everything will ultimately become 0, right? That means the derivative of my function is nothing but under root x sine x, right? So obviously it's very much clear that in this interval, you can't have any value of x for which this will be undefined, right? So the undefined case is not necessary, it's not needed for me right now. I need this 0 case. So where all can this derivative be 0 in this interval, right? So 0 is not included in the interval, so I can't take it. 5 pi by 2 means I start from 0, I cover a pi, I cover a 2 pi, I cover a 3 pi, right? 3 pi, this is 2.5 pi, right? So it's 5 pi by 2. So you start from here, cover a pi, this is 2 pi plus pi by 2. 2 pi plus pi by 2 is 5 pi by 2. That means you can go here, come here, and then you have to stop here, right? You're not supposed to cross this again. So that means between 0 to 5 pi by 2, which is 90 into 5, which is 450 degrees, you can choose any value. It's very much clear that between these two values, your sine will be 0 only at pi and 2 pi. So when it starts from here, 0 could satisfy this, but 0 is not there in the interval, so I'll leave that. Nowhere else sine will become 0. Here once again it will become 0 at pi, right? At pi. And after that nowhere it will become 0 again. And here at 2 pi it will become 0 again, right? And then as you keep going, you have to stop here anyways. So there are only two values in the middle where this function will become 0, right? So your x is equals to pi or 2 pi. And that is the reason why you have only pi's and 2 pi's in the options, right? Because one of them is a local maxima now and one of them is a local minima. Or I actually can't say that, right? For that, what I'll do is I'll use the second derivative test, right? Second derivative test. Or in fact, instead of using the second derivative test, you could also use the first derivative test to estimate whether this is minima or maxima, and also whether this is minima or maxima. I'll rather use second derivative test. So second derivative test means I'll have to differentiate this function once more. So what I'll get is 1 by 2 root x into sine x, 1 by 2 root x into sine x, plus root x into cos x, right? So you can either use this, so sin x plus x cos x by 2 root x. This quantity will anyways be positive, right? This quantity will anyways be positive. I need to check at pi. I need to check the sign of the second derivative at pi. So I'll put pi in this expression. If I put pi in this expression, what I'll get is f double dash of pi is nothing but sin x will become 0. This is pi into cos pi is minus 1 divided by 2 root pi. That means it is minus of pi by 2 root pi, right? So it is negative obviously. So f double dash of x at x equal to pi is less than 0. And if you check for 2 pi, once again this part will be 0, this will be 2 pi, and then this will be 2 pi into 1 instead of a minus 1. So there is no negative sign coming when you put 2 pi in this expression. So obviously f double dash of x at x equals to 2 pi is positive, right? Remember, whenever second derivative is positive at some function, at some point, then that point is a point of minima. When it is positive, then that point is the point of minima, and when it is negative at some point, that point is the point of maxima. So at x equal to pi it's negative, so x equal to pi is point of maxima, and x equal to 2 pi it is positive, so x equal to 2 pi is a point of minima. So it is maximum at pi and minimum at 2 pi. It is maximum at pi and minimum at 2 pi. So this is the option actually. It says it is minimum at 2 pi and maximum at pi, and that is what I got. So the answer is the second option.